Hello, hello, hello! Welcome back. It is Monday, the 23rd of February, and today I'm going through the Stats and Mech paper for the 2024 summer cycle. Apologies for being slightly late on arrival. It turns out that if you want to start at 11, it typically helps to have the papers downloaded like a little bit before 11. Who knew? Oh. But yeah, so today I'm just going to go through that paper. Note that, 6 people live on a Monday. What? And you guys should be in school. Half term's over now. But yeah, so I've set up the Discord server. Oh, nope, gone. The numbers are just going wild. Discord server is up. Discord server is very active. And I'm sort of keeping track of that. If anyone wants to post anything in the help or the streaming suggestions, please feel free. There's also a general chat, which is also very open. I need to do definitely some admin, and I think I'm going to take the time off that I'm taking this week to kind of think about how to make that the best resource possible, as well as things I can do here to build out the channel, things like a better profile pic and kind of how I want to do this moving forward. Always open to suggestions, and whoever's here, helping you guys out as much as possible, feel free to let me know, and you can kind of contribute your feedback. So without further ado, and also for anyone who's sort of new here or finding this in a sort of, video after the fact, what I do here is once a week, I do a live solve of a paper to go through mostly the exam technique when it comes to doing a math paper. And once a week doing a sort of physics seminar where I describe a topic in the sort of evening when more people can show up, ask some questions, all that kind of stuff. Because I find physics easier to teach and math easier to just demonstrate. And I think it's good as well. Like with the past papers that I've done before, there's like math, you can understand it. I understand the math, but there's always these teeny tiny little like execution mistakes or exam technique mistakes that stop you from doing your absolute best. And it's important for you guys to see that I make those too. So like last time when I just straight up didn't see part of the question and just skipped it and lost 2 marks for that, little things like that make you go, oh, okay, no, it's easier than you think to make these little mistakes. And so it becomes a much more sort of like forward part of your process. You're thinking of it. It's much more front of mind. So without further ado, let us get into it. So we're going to share this window. Make sure you guys can see it. Good. Now, as always, I'm going to, in fact, let's have a little discussion first. So with the stats of the mech, it kind of comes in 2 bits. And there's an obvious strategic choice here, which is, do I do the stats first or do I do the mech first? And that's going to be a very personal choice. For me today, I'm kind of feeling stats first because it's much more methodical. You can kind of get into it and get it out of the way. It's a lot less fun. I think mechanics requires sometimes a lot more thinking. And so I'm going to just power through the stats and then give myself the space and time to finish the mechanics with a bit of fun before I go back to check. Speaking of checking, that's one of the main things I want you guys to pick up on is how I go and check my work, which is one of the best things I did in the Pure, is how do I spot the execution mistakes and how to correct those. So I'm going to start with the stats and let's get into it. Cool. Zooming in so you guys can see. Perfect. I am going to time it, but I'm not going to hold myself too religiously to it because I'd like to take some time to explain what I'm doing on the way and do a very decent check. So let's go. Let's also check how good my calculator skills are. Rolls of fair die 10 times. As soon as I see 10 times, I'm immediately going, right, this is going to be binomial distribution. Random variable x represents the number of times it lands on a 6 using a suitable distribution. Well, this on my calculator is going to be the PDF of 3. Do I want to do this on I suppose I have to do it on the calculator. Can I remember how to use the calculator? Let's find out. Actually, no, I prefer the CG50 for this. So I'm going to pick up my CG50. That's the others. Guys, I cannot tell you how much I hate tech. Like, I really wanted to just do math. Like, why do I have to know how to press buttons? Oh, the probability. No, you're right. Not the problem. What am I talking about? The CDF. No, I am right. So it depends. So you might call it the PD instead. So maybe you call it the BPD for binomial probability distribution, something like that. But it's the PDF as opposed to the CDF. So there's the one that lets you work it out for when a value is equal to 3 and the one for when it's like less than and equal to 3. So if I go to Okay, let me just, nope, accidentally turned it off. Going so well. So menu, there we go. Stats, let's do this. That one, can I remember how to press my buttons? Maybe I can't. All right, I'm gonna do it by hand. So when it's equal to 3, because I don't want to waste time with all this kind of stuff, what we're gonna do is it's gonna be equal to, well, that's the top tip. No, make sure you know what buttons to press in which order. But this is going to be equal to 10, choose 3. The probability of getting a 6 is a 6, and you do that 3 times. And then you fail 7 times. And that's going to be equal to, this I definitely know how to do. Also, guys in chat, if you've got fancy calculators and you can just remind me which buttons to press, I don't think that counts as cheating. Cubed, or you can just watch me struggle entertainingly because I am, as you quote unquote, unk and do not know how to press buttons. Always quoting probabilities to 4 significant figures. Now, I definitely need to know how to do the PDF. Okay, so I think I just pressed the wrong option. I think I didn't need stats. I think I needed distribution. Where's that? Distribution, there it is. So if I select this, and we're going to do the binomial distribution. We're going to say x is equal to 3. Well, in fact, for this second one, what we need, and this is a classic, it's making sure that, remembering on your calculator, the cumulative distribution function is strictly less than or equal to. So we need to convert that into a less than or equal to. So that's going to be less than or equal to 2. So it's going to be the CDF or the BCD or something like that, however you know it, or the CD of 2. So menu, one binomial. Menu, it's menu. Calculate complex, space, 7, distribution. Select that one. There we go, yes, okay. So on my calculator, so for instance, if you have the old Casio, if you go to menu and then 7 for distributions, I see normal PD, normal CD, inverse normal. And then this first one, I could have done normal PD, which is option 4. And I would do variable. X would have been equal to 3. Number is 10. Probability is 6. And if I do that, I get exactly this, the 0.1550. And then if I go back again, so I'm going to re-enter this, only instead of doing normal PD, I'm going to do normal CD on variable. And this would be, get x is equal to 2, n is equal to 10, probability equals to 6. And I get 0.7752. Right. This is why we do stats first, through the worst of it. Just write an equal sign. Okay, and most other syllabuses, you deal mostly with this less than or equal to. Right, so he repeats the experiment every day for 60 days, records the number of days when x is equal to 3. Well, that happens with this probability. Find the probability. So this is what I call a nested binomial. So we're going to define a variable y, which is going to be the number of days when x equals 3. And that will be distributed binomially. So he does it for 60 days. And the probability that x equals 3 is the 0.1550. So find the probability that there were at least 12 days, means the probability that x is bigger than or equal to 12. But remembering that the cumulative distribution is strictly less than or equal to, I have to write it in the right form. So drawing my little number line, if 12 and up is in, then 11 and below is out. Which means it's 1 minus the probability that y is less than or equal to 11. So it's going to be 1 minus the cumulative distribution for 11. And then if I go back, so the cumulative distribution, I'm going to type 11. And n equals 60, and p equals 0.1550. And when I run that, I get 0.7885. And I'm going to do I'm going to go back to calculator mode. And I'm going to do 1 minus that answer and get 0.2115. Cool. Find an estimate for the total number of sixes we'll roll during the 60 days. Well, an estimate is going to be, so there's 60 days. And he repeats the experiment, which is rolling it 10 times. So there are 600 rolls. And so the estimate would be 100. It's NP. It's 600 times the probability, which is a 6. So you're going to get your 100 from that. So use a normal approximation. Okay, so normal approximation to binomial. I'm going to have to be I immediately know that the trap here is the continuity correction. So to estimate the probability that this person rolls a total of more than 95 sixes. Right. Welcome from India. So we've got more than 95 sixes. So this is 600 rolls. So if we define an x as being distributed binomially with 600 rolls and a probability of a sixth, I'm redefining my x and y from before. Then y would be distributed normally with, well, the mean would be equal to n times p. So it's 600 times a 6, which is the 100. So the mean would be 100. And the variance, I know, is n times p times 1 minus p. So the standard deviation is the root of 600 times a sixth times 5/6. And if I run that on the calculator, I get square root of 600 times a sixth times 5/6, which is 9.1287 squared. So I know what I want here. Now I can afford to scroll down a little bit. Because now I've worked out the mean and the standard deviation. So in the binomial, the probability that x rolls a total of more than 95, so bigger than 95, I'm going to again draw my number line and say if that's 95 and that's 96, we want everything bigger than 95, so that's going to include everything in 96, but I'm going from discrete to continuous, so I know I actually need to include everything from 95.5 and above. So this will be equal to the probability that y is bigger than 95.5 on this normal distribution. So now I know what I'm doing. I have to go to my normal distribution. So I'm going to go to menu, distribution. We're going to do the normal CD. And I'm remembering as well that the lower would be 95.5. The upper would be a stupidly large number. So I'm going to put 9 times 10 to the 99. My standard deviation, I know, is the 9.1287. And the mean, I know, is 100. And the probability I get is 0.6890. And this makes some sense because on a normal distribution, if that's 100, then I know that if I'm going from 95.5 and above, that is going to be bigger than 0.5. So sense check, that seems okay. So that's what I think the answer is there. Now, as you can see, the worst part of my game is how to press buttons on calculator. So hopefully I'm through the worst of that now. Question 2. Right, so we've got studying the flight of a bird from a nest. He measures the bird's height above the ground, h meters, at time t seconds for 10 values of t, and finds a regression line. So this is telling us the relationship between the height and the time. So I'm going to interpret the height starts at a certain value, and as time progresses, it goes down at this sort of rate. So I'm going to interpret that as the speed of the bird. Is 1.28 meters per second, and I'll say it's going down because the height is decreasing. So the product moment correlation is not great. Test whether or not there's evidence of a negative correlation between the height above the ground and the time during the flight. All right, so this is a... what I didn't do, I'm going to pause real quick because I need to get the formula book, which I have in here, I think. Yeah. Okay. So what I need to do is to show you, because I know with this one, this is not a calculator thing. This is a one where you look up values. Great. So if I come to here, standard deviation, for the math, where was the stats? Hold on a minute, because there's the tables. So maybe the tables are after everything. Statistical tables, that's for binomial. Here we go. Nope, that's normal distribution. Cumulative distribution, chi-squared. Where's my... There we go, correlation coefficients. Okay, so here we have 10 values of t. So sample size is 10. We want to use a 5% level of significance. And we want evidence of negative correlation. So the null hypothesis is always 0, that it equals 0. And the alternative in this case is that it's negative, so it's going to be less than 0. This is a one-tailed test, so what I'm going to look up is the critical value, 5%, n equals 10, and I get this, 5494. Let me zoom in a little bit more so you can see better. So sample size, n equals 10, product moment correlation coefficient for 5% is 0.5494. So I know my critical value is minus 0.5494, minus because we're testing for negative. We find this. Now, the way to think about hypothesis tests is about extremity. Is my value sufficiently extreme to justify rejecting it? And in this case, our value is not more extreme than that. So what I'll say is minus 0.510 is bigger than minus 0.5494. So we do not reject. And stating it in the language of the question, no evidence of, and I'm not even going to bother writing this down. I would just, in the exam, I would write, there is not evidence of a negative correlation between the height above the ground and the time during the flight, because it is insufficiently extreme. So you got, remember, number lines really help to visualize these things. If I have minus 1 and 1 are the most extreme, I know in order to be out, you need to be more extreme than minus 0.5494, but we're not that extreme. We're only up to 0.510. So we're not sufficient to cross that red line that would lead to rejection. With reference to the scatter diagram, state giving a reason whether or not this is an appropriate model. The data points do not lie close to a straight line, therefore it is not an appropriate model. I'm not going to bother writing that down. That's the answer. James, and you'll notice, like, look how like repetitive that was. I was like, oh, it's just this, because they like these certain things just said in the language they like over and over again. So Jane suggests an improved model using a quadratic. She changes. Okay. Choose a suitable value for k to write Jane's improved model. Well, this is, if we think about it then, a suitable value of k. Well, when t is equal to k, u will be equal to 0. So the height would be 38.1. So in other words, as well, Let me rewrite this. So that would be 38.1 minus 0.78 into t minus k all squared. Now, I know sort of from vertex form that this would give me the maximum when t equals k. So if I look at the maximum data point, that's here. It's 40. It's not 38.1, but the data don't have to fit precisely. But this seems to be when t equals 3.5. So I'm going to say that k is equal to 3.5. And then I'm going to move on with my life. Oh, large data set. Woo! Here it is. I hate the large data set. Everyone hates the large data set. You all have to know it. I don't necessarily have to know it, but hey, I'm in the hot seat, so I'll show you what happens if you don't know it. But maybe I will. So we're studying the large data set for Perth in 2015. So things you need to know for large data set. It is October to May in 1987 and 2015. And you need to know all of the 11 column headings and the types of data they contain. So let's see what comes up here. And also the 8 locations. All the data available to find summary statistics for daily mean air temperature. Selected an incorrect value on the spreadsheet. The incorrect variable gave a mean of 5.3 and a standard deviation of 12.4. Oh, God. I've never seen a question this bad where you actually have to know the values it contains. Wait, what would be a mean of 5.4 and a large standard deviation? That's unlikely to be daily total rainfall. Maybe it's maximum wind speed. Daily max wind speed is what I'm going to go for. Because rainfall would be a lot less than that per day. So I know there's a daily max wind speed, which is quantitative, and you expect to have a large standard deviation, but would be quite low. I'm going to go with that. So correct values for the daily mean air temperature are this. Calculate the mean and the standard deviation. This is quite fun. So the mean is given by sigma x over n. So 2801.2 all over 184, which is, oh, no. Guys, you know what I'm failing at. I can't press the buttons. No, it was still in the distribution mode. So 2801.2 over 184 is 15.22 for the mean. And the standard deviation is given by the root of sigma x squared over n minus mu squared. So it's the root of 44695.4 all over 184 minus, I'll do this one precisely because the mean was not precise, 2801.2 over 184 squared. So in my calculator, I'm going to do root of 44695.4 all over 184 minus answer squared. So it's precise. The standard deviation is 3.338. Now doing it so I'll do it the same number of significant figures as they gave these. So I'll say 15.2 to 3 significant figures and 3.34 to 3 significant figures. So that's the mean and the standard deviation. One of the months from the large data set has that mean and that standard deviation. Suggest giving a reason, a month that these data may have come from. Well, this is daily mean air temperature. That's a high temperature. And I know it's May to October. And but it's Perth. And Perth is in Australia, which is in the southern hemisphere. So I know that the summer there is the winter. So I'm going to say October, actually. Because it's Australian spring. So you're expecting kind of because it's May to October, and May, June, July, August would definitely be their kind of fall going into winter period. And so I'd expect coming into spring it to get hotter again. So I would go with October. But that feels a little, you just got to know how the world works. But hey, this is why we start with stats to get it out of the way. And we're only about 20 minutes in, so I'm feeling good on time. The proportion of left-handed adults is 10%. So this is going to be a hypothesis to test, and it's only different without direction, is what I see here. She takes a sample of 40 adults. This feels like a binomial hypothesis test because she's taking 40 adults and we're testing a probability, not a mean. So find the critical region. Okay, so state your hypothesis clearly. Well, the null hypothesis is going to be that the probability is 0.1. The alternative hypothesis is going to be that the probability is different from 0.1. So we need to have it. This is going to be a two-tail test, and we need to find the critical region in each tail. So we have 40 adults, and it's a 5% significance level. We're not told to take the probability as being as close to 2.5% in each tail as possible, which means if I love a number line in stats. So there's kind of this number line here where there is 0 on one end and 40 on the other. And there are going to be these sorts of red lines in the sand, which is your critical region. And what we need is that the probability of being more extreme than those is going to be 2.5% in each tail. And only if you lie within that critical region are you significant enough to reject. So what we have to do is to find where these lines in the sand are. So if we assume a binomial distribution, so we assume H naught is true, so X is distributed binomially. We have 40 adults, right? Yeah, 40 adults. So it's distributed binomially with 40 and 0.10. We need to work out, we have to do an inverse binomial here. So can I remember how to do an inverse binomial? No, so we have to do this from list function. That's it. So I'm going to do this from the list function. I'm going to go to binomial CD list, and I'm going to try 0, 1, 2, and 3 for n equals 40 and p equals 0.1. And my list gives me that the probability that x equals 0 is 0.0147. And the probability that x is, in fact, let me see if I can zoom in a bit more. Yeah, there we go. Is that too much? A little bit too much. That's fine. I'd rather be big so you can actually see. So the probability that x is less than or equal to 1 is 0.0804. So what that tells me is 0 is sufficiently extreme. But so the 0 is there, but the 1 is there. Being less than or equal to 1, not sufficiently extreme. So therefore, this probability of x equals 0 is going to be in my critical region. Now I need to consider what's happening on the other side. So on the other side, that's going to be harder. So on this one, I knew it was going to be quite low because my mean value would be 40 times 0.1, which is 4. So I know you have to be less than 4 to reject it all. Bigger than 4, though, it's going to be a bit trickier to spot. So I'm just going to firstly do it every sort of 5. So I'm going to try 10, 15, 20, 25, 30, 35, and see what that gets me. All right, so even 10 is really extreme. So I'm seeing on my calculator that the probability, because remember, we want the probability of being bigger than that should be 2.5. So the probability of being less than that should be 97.5%. But the probability from my cumulative distribution of being less than or equal to 10 is already overshooting that mark. I'm 9985. So that tells me I need to go even less than 10. So now I'm going to try 6, 7, 8, 9, 10 on my list. and I see that that transition happens. Right, so I can see that the probability that x is less than or equal to 7 is 0.9580. Sorry, 9581. So you should always click in to make sure it's not accidentally rounded. And the probability that x is less than or equal to 8 is 0.9845. And in fact, I should really go back and check I haven't done that on... So when I'm checking, I'll go now and check I didn't do that with my zeros and ones. I did. That shouldn't be 804. So what you have to do is you have to click into the value, because right now it truncates it. So I see 0.0804. But if I click into that, it sort of cut it short. And it's actually 0.08047, which should have rounded to 0.0805. So that's just a bit of a calculator skill there. And the 0 similarly should have been rounded to 0.0148. Really easy to forget about that, actually. So important that you don't. So these probabilities are now correct, and I'll make sure to check those when I'm checking. So the probability, so the transition happens here. So this is the critical region, and this is the critical region. But I need to convert that. Therefore, what I'll write just for completeness is therefore the probability that x is bigger than or equal to 8 is 1 minus this, and probability that x is bigger than or equal to 9 is 1 minus this. So if I go back to calculator mode and just work out what those are, well, in fact, no, I'll just do it by eye. 0.0419, 0.0155. So we find, therefore, the critical region is going to be given by let's do it set notation. So if with x, it's going to be x equals 0 unioned with x is bigger than or equal to 9. So that's my critical region. So showing that here, 9 is sufficiently extreme, 8 is not sufficiently extreme. So 8 would be about here, 9 would be about here, and that's 1 and that's 0. And we can see our lines in the sand showing us what's significant. So let's zoom out and get a look at this question again. State the probability of rejection in each tail. I have done that. That's the probability of rejection. That's the probability of rejection in that tail. Cool. So part B, write down the actual significance level. The actual significance level is the probability of rejection, which is the sum of the probabilities in the two tails. So was that actually B? Yeah. So B would be equal to the sum of 0.0148 and 0.0155. Right, plus 0.0155, which is 0.0303. And that is the significance level. In Freya's sample, 7 adults were left-handed out of 40. 7 is not in the critical region, so do not reject. Do not reject. And I won't rewrite it this because you don't want to watch me just write this all out. But what that would mean in terms of Freya's belief, I would state it in the language of that. Therefore, there is not evidence to support Freya's belief that the proportion of left-handed adults under the age of 25 in this country is different from 10%. So I would always just restate the question in like the language of the question in my answers there. Won't do it here because no one wants to watch me like write out a sentence, but yeah, in the real thing, definitely do. Records for a school athletics club show that the height is normally distributed with a mean of 1.4 and a standard deviation 0.15. Find the proportion of these students achieving a height of more than 1.6 meters. So I'm going to come down here and just write things out. So H is distributed normally with a mean of 1.4 and a standard deviation of 0.15. And we want the proportion of a height being more than 1.6. So what is the probability that the height is big? Nope. Height is bigger than 1.6. Menu. Okay, so reminding myself how to press buttons. Yes, this is going to be the normal CD, where the lower is going to be 1.6. The upper is going to be a stupidly big number, 9 times 10 to the 99. Standard deviation, 0.15. Mean, 1.4. I expect from a normal distribution curve, if that's 1.4, if I go 1.6 and above, I expect it to be, and that's outside one standard deviation as well. So if it was 1.55, I would expect 2/3 to lie within that. No, I think it's 68%. So 0.34, I'd expect it to be around 0.84. So I expect this to be bigger, even bigger, or even, sorry, even less. Let me talk to you about what I'm doing with my sense check here. I always keep a sense check with the normal distribution, where if that's the mean, I know within one standard deviation, it's going to be 0.68. And because of the symmetry, I have this, which leaves a remaining 0.16 in both of these tails. So it would be, if it was 1.55, I would expect the probability of being bigger than that to be 0.16. This is even bigger than that, so I think the probability should be less than 0.16, and my calculator gives me, right on cue, 0.0912. Great. Always worth doing that. Make sure you really know your distribution curves so you can sense check your answers and sort of track to see if you've made a mistake typing something in, which is so much easier than you think it is to do. So the school's head would like to use these distributions to estimate the proportion of students from the school athletics club who can jump higher than 1.6 and can run 1,500 in less than 5 minutes. So state a necessary assumption about H and T to calculate an estimate of this proportion. I'm just going to say independent, because this is the independence test. What we're going to have to do is to get the probability of running 1,500 meters in less than 5 minutes, multiply them together, but that is only true if H and T are independent. So find the estimate of this proportion. Well, what we need to do is to work out if T is distributed with a mean of 300, is distributed normally with a mean of 330 seconds and a standard deviation of 26 seconds, then what we have to do is to work out the probability that that time is less than 5 minutes, which is 300 seconds. And the probability of that, if I go into my normal CD once more, I need to put in a lower value of negative 9 times 10 to the 99, an upper value of 300 with a standard deviation of 26 and a mean of 330. And when I do that, I get probability is 0.1243. So then, assuming they're independent, so we are allowed to multiply, I will say that 0.0912 times 0.1243 is, and then going back into calculator mode, I'll be able to type that in without any fuss and get an answer, which is 0.0113. So in other words, a 1.1% chance, basically. Now, that's not likely to be a very accurate assumption. I think they are not likely to be independent, but hey, they didn't ask us about that. So students in the athletics club also throw the discus. Why? The random variable D distributed normally. So this is going to be an inverse normal using the standard normal in order to work out the mean and the standard deviation. So here, in fact, I'm going to have to do this. I'm going to write down all the information so I don't have to keep on hopping back and forth. So probability of D being less than 16.3 had a value of 0.30. And similarly, the probability that D was bigger than 29.0 had a probability of 0.10, and we need to use that. So what we can do is we could instead convert this into the standard normal. Based on the size of that, this would have 0.10 in this tail, and this going downwards would have 0.30 in this tail. And that would be from the 16.3. Now, what we have to do is to work that out on a z-score, like a z standard normal. So I'm going to say that z is distributed normally with a mean of 0 and a standard deviation of 1. And we want to do the inverse normal to work out what the z values must be in these two tails. So going back to distribution, we're going to do 3 for inverse normal. Remembering that the area is going to point to the left. The first area will be 0.3, standard deviation 1, mean of 0. I get a z value of minus 0.5244 on that tail. And then going back, if I instead select an area of 0.9, remembering that it always points left, this z value would be 1.28155. So what that means is, and remembering as well that z is equal to x minus mu over sigma, it means that minus 0.5244 equals x of 16.3 minus mu over sigma, which means that minus 0.542, this number sigma is equal to 16.3 minus mu. And I know that 1.28155 sigmas is equal to, this zx value was 29.0. So 29.0 minus mu over sigma, which means that 1.28155 sigma equals 29.0 minus mu, which sets up some nice simultaneous equations here on the right that I can solve. I'm going to eliminate. I'm going to do the bottom equation minus the top equation. So if I go back to here, if I add that and the 0.5244, I get that 1.80, well, I'll call that 1.806 sigma. From doing that minus that is equal to 29 minus 16.3, which is 12.7. So that minus that is 12.7. That minus that eliminates. So I can immediately get that sigma is equal to 12.7 divided by 1.806. So the standard deviation is going to be 7.03. And by plugging that into the second equation, I can rearrange for mu and get that mu is equal to 29 minus 1.28155 answer, and get that the mean is 20.0. Let's see if they wanted that to a certain number of significant figures. The standard deviation was, they gave everything to 2 significant figures. But here these x values are 3 significant figures. I'm going to say, so these are, I think that should be fine. I think that should be fine. I don't think they're going to do anything too nasty on the rounding. And there's a question 6. I thought there were normally only 5 questions. All right, we'll roll with it. It's all right. We're doing great on time, especially because I wasted so much time remembering how to press buttons. So state any pair of mutually exclusive events. Well, we know for certain that A and C are mutually exclusive because their circles do not overlap. You could also have B and D. You could also have A and D. The events B and C are independent, which means that, therefore, probability of B intersection C will be equal to probability of B times probability of C. So what we can say because we're trying to work out from this the value of P there in the middle. So because they're independent, the probability of B and C, so the 0.27 from part B, the 0.27 would be equal to the total probability of B, which is the sum of all three of these, which is 0.32 plus P, multiplied by the total probability of C, which is the sum of all of those probabilities, 0.27, 0.25, 0.08, and that would give you 0.6. And this is a simple equation you can solve for P. So it's 0.32 times 0.6, which is 0.192 plus 0.6P, which means that 0.27 minus 1.92 gives 0.078, which is 0.6P. Divide this by 0.6, and you're left with the fact that P is equal to 0.13. Cool. Find the greatest possible value. Well, I'm going to first note this on as being 0.13. Find the greatest possible value of the probability of A given not B. Well, I know that the probability of A given not B is the probability of A and not intersection not B all over the probability of not B. So the probability of A and not B is Q. The probability of not B is actually known precisely, isn't it? Yes, because we can do 1 minus everything in B. So everything in B is 0.05 plus 0.27 plus 0.13. So everything in B is 0.45. So if it's not B, that's 0.55. Okay, so what this means is we have to find out something about Q. Well, what we know as well is that Q plus R is equal to 1 minus all of these probabilities. So 1 minus 0.05 minus 0.13 minus 0.27 minus 0.25 minus 0.08 is 0.22. So the biggest that Q can be is when R is equal to 0, and then Q is equal to 0.22. So that's the biggest I can ever make Q be equal to. So I'm going to run that in. 0.22 over 0.55 is obviously just 2/5, which is 0.4. I'm going to run it anyway and get, yep, 0.4. That's for C. So given that probability of B given not A is 0.5, we want to find Q and R. So the probability of B given not A is going to be the probability of B and not A all over the probability of not A. So probability of B and not A is these two, is 0.13 plus 0.27, which is 0.4, all over the probability of not A, which is all of these guys, the 0.13, the 0.27, the 0.25, the 0.08. So 0.73 plus R. And this is a simple equation that I can use to solve for R. So 0.73 plus R is equal to 0.4 all over 0.5, which is obviously 0.8. Yes, it is. Which means that R is equal to 0.07. And as we saw from before, Q plus R was 0.22. So Q is equal to 0.22 minus 0.07. 0.07 is 0.15. Okay, so that's Q and that's R. Great. Find this monster. Well, let's see if I can do that directly. So Q is, hold on, what was it? Q is 0.15, R is 0.07. And we want to find the probability. So it's A or B, knotted. So that's everything else. So the probability of A union B and then not that is that's everything in A, that's everything in B. Unify those, and it's everything that's not those. So it's these three on the outside, which is 0.07 plus 0.25 plus 0.08, which is the 0.4, just to make a note to myself. So it's that intersected with C. So it's these three intersected with C. Well, that's these two. So that's going to be 0.25 plus 0.08, which is 0.33. Use set notation? No, I don't think I will. To write an expression for the event with probability P. An expression. So we want it to be B. In other words, we want it to be, so what we could do is it would be the probability. So for F, it would be the probability that, in fact, let me write it up here. So for F, it would be the probability that you would have, let's try, so one version of this would be A union C, knotted, so not any of that, which would leave you with just these two. And you would need to intersect that with B. And that would be one way of isolating P. So that's going to be my final answer there. And that, I think, yep, that's the final one. So I took 50 minutes on that, longer than I should have, but again, I was faffing and explaining. So hopefully I'll make up some time here. And again, I'm happy to overrun a little bit for the checking because I'd rather give up on time a little bit just to kind of do this properly so you guys can all follow. So rough horizontal plane, find the magnitude of the normal reaction. My mass 0.5, I'm gonna, nope, too thick. Whoop. Okay, so that's gonna be 0.5 G. We're gonna have a normal reaction force. We're gonna have some friction. No, it's at rest. Find the magnitude of the normal reaction, 0.5 G. So 0.5 times 9.8, let's call it, so it's 0.5 G, which is 4.9 newtons. Coefficient of friction is now 2/7. Horizontal force of X is applied, and it's in limiting equilibrium, which means that the friction is equal to mu r. So X is equal to mu times r. So it's 2/7 times that 4.9, which is 1.4 newtons. Oh my God, that's it. Oh, I love these. I love a good distance speed time graph. Cool. So running a 200-meter race in bold. So I'm going to make a note of that in 24 seconds. So the total distance is 200, which means that the total area under the curve is going to be 200. So then it just sort of describes what's happening in the graph. And we have to find the acceleration during the first 4 seconds of the race. So in the first 4 seconds, the acceleration here is going to be the change in speed, which is 10 over the time of 4, which is 2.5 meters per second squared for A. Stating a unit's good. Find the distance covered by the athlete during the first 18 seconds. Well, the distance is area under the curve. So I'm going to do the area of, in fact, I'm just going to go straight to the trapezium, and I'm going to say it's the average of the parallel sides. So for B, the distance is equal to, these are my two parallel sides. They have distance 14 and 18 respectively. So it's going to be 14 plus 18 all over 2, multiplied by the distance in between, which is 10. And doing that, it's clearly going to be 16 times 10 is 160, but I'll just type it into the calculator anyway for belts and braces, and that is 160 meters. Now, find the value of u, therefore. Well, what that means is this remaining distance I know has to be 40 meters for the area of this trapezium. Now, the area of this trapezium, I see another trapezium. The parallel sides have a length of 10 on this side and a length of u on this side and a distance in between of 6. So I know that 40 is equal to, in fact, I can zoom in a little bit more just so you can see a bit clearer. But that 40 is going to be equal to the average of the parallel sides times the distance in between. So canceling those two for 3, it's going to be 3u plus 30, which means that 10 is equal to 3u, which means that u is equal to 10 over 3. Okay. Find the value. Great. I love mechanics, guys. Really do. So here, particle is held at a point on a rough inclined plane. As soon as I see something like this, I don't even care what's happening now anymore. I'm just going to stop and write this out. So if tan alpha, I'm going to draw some random triangle. I'm going to call that alpha. I know that tan is 5, opposite over adjacent, 512. I know this is a 512, 13 Pythagorean triple. I'm going to confirm it to myself by doing Pythagoras, and yep, that's 13, which immediately means that cos of alpha is 12 over 13. And sine of alpha is 5 over 13. Those will be helpful. Okay, so we have a range on mu, which is it's less than 5/12. The particle is released from rest and slides down the plane. Right, well, that's going to be a weight down mg. That's going to be a normal reaction force of r. It is sliding down, which means that the friction acts up. And because it is moving, I know the friction is equal to mu r. Right, so find in terms of m and g the magnitude of the normal reaction on the plane. You have your chemistry board exam on the 28th and you're watching math. Hey, do you know what? Brain stretching is brain stretching. Listen to me to the way I'm sort of like, oh, look at me nice and logically go through the questions and then kind of adopting that pattern to maybe help you. There's a transferable skill, I'm sure, that you can find useful. So we got to find the magnitude of this normal reaction. And the way we're going to do that, so we're doing it in terms of m and g. So by resolving perpendicular to the plane, we know that r is going to be equal to mg cos alpha. And the reason why, if I kind of draw that for anyone who needs this, if I draw that mg a little bit bigger, then I can draw a triangle with components parallel to and perpendicular to the plane, where this angle will be alpha, because if I extend this even further, this would be 90 degrees, this would be 90 minus alpha, and because that is a 90-degree angle, that means that these two add to 90, so there's an alpha in there. Is this trig? Yes, this is trig. So this is resolving forces using SOHCAHTOA, which is a very common skill in the mechanics. Now, I know from what I did before that cos alpha is 12 over 13, so the reaction is 12/13 mg. Cool. And I'm going to write that down here as well so I remember it. Coincidence. Super handy. Right, so show that as p slides down the plane, the acceleration is given by some nonsense. How are we going to do this? Well, if that is r, then I can, so that's A. I'm going to just do all my stuff here so you have the diagram. But for B, what we're going to say is it's accelerating down the plane, right? So the acceleration is that way, which means I'm going to resolve down the plane and say that the component of weight acting down the plane, which would be this guy down here, which would be mg sine alpha minus mu r, will be equal to ma. So the mg sine theta acts down in the direction of the acceleration. The mu r acts up the plane against the acceleration. That will be the resultant force. And F equals ma. Resultant force equals mass times acceleration. So sine alpha was 5/13. So 5/13 mg minus, and we want it in terms of g and in terms of mu. So mu times this r, so that's going to be 12/13 mu mg equals ma, and the m's cancel. So it's going to be 1/13 g into 5 minus 12 mu. Perfect. And then C, state would happen to P if it was released from rest, but mu was bigger than 5/12. Well, if mu is bigger than 5/12, then mu r, which is F max, would be bigger than 5/12 times r, which would be bigger than this 5/13 mg. But the weight acting down the slope is 5/13 mg. In other words, the weight acting down the slope would not hit the maximum friction. So it would stay at rest. It would not have sufficient force to overcome the friction to start to move. Okay. Question 4. Whenever you see this solutions relying entirely on calc tech are not acceptable, that means this probably could just be done using your GDC. It does mean if you have one, then you could use your GDC to sort of guide you and let you know if you're doing the correct thing. But you still need to have the requisite math, graphics calculator, GDC, graphics display calculator. So the fancy ones, the sort of CG50 types. I don't know how to press the buttons. It's like my weakest part of the math, but a lot of people do know how to press the buttons. And if you're one of those people, that's your warning that or your clue that actually maybe you can use your graphics calculator to assist you in this question. So here we have the position vector as a function of time. When t equals 4, the bearing of P from O is 135. Show that C is 3. Okay, so this is position vector. I'm going to draw this out. So there's an origin. I'm going to draw my north arrow at the origin. This is where P is. This angle is 135, which, by the way, I haven't drawn it very well. It means that that angle in there is 45. Which means, because that's a 45-degree angle, that's acting parallel to I minus J. So because that's a 45-degree angle, and that's a right angle, and that's a 45-degree angle, not as I've drawn it. So let me redraw it so you can see it a bit better. So if it's on a bearing of 135, let's draw this out a little more accurately. Whoop. If the total is 135, and it's 90 degrees from the vertical north arrow to the horizontal, that gives you a remaining 45 degrees in there. And again, the angle between vertical and horizontal, 90 degrees, giving you 45 degrees down here. That makes this an isosceles triangle, letting you know that the amount it goes across is the same as the amount it goes down. So what we know, therefore, is that the amount it goes across, which is ct to the half, when t equals 4. So let's plug that in. So r, when t equals 4, is going to be given by 2ci. And then 3/8 of 16 is going to be 6. Again, I'm just going to run that on the calculator to make sure I didn't do something silly, and I didn't. So minus 6j. What that means is, therefore, 2c is equal to 6 and c is equal to 3. Because it's, and I would need to write out some sort of sentence to justify that the amount, but I've done that here, so I know what I'm talking about. I'll see in the marks team how they want you to justify that, but this feels good. Find the speed when t equals 4. Well, I can find the velocity vector by differentiating with respect to time. And that would be a half ct to the minus a half I minus 3/4 tj. And when t equals 4, the velocity vector, well, first of all, let's go back in. Our c was equal to 3, so let's make that 3/2. And so this would be 3/2 root t, so that would be 3/4 I minus 3j, which means that the speed is going to be the Pythagorean triple there. I say so it's 3/4 across and 3 down. So I'm going to do Pythagoras on that to work out what the speed is, because it asks for speed and not velocity. And that would be 3.09, and it is in meters per second. When t equals big T, p is accelerating in this direction. Well, acceleration, I'm going to differentiate again. So the acceleration vector will be given by minus 3/4 t to the minus 3/2 I minus 3/4 j. And it's in that direction, which means it is parallel to that, which means it is a multiple of that. So by looking at the j parts, I'm going to be able to work out what k is, this sort of scale factor. So what that means is that minus 3/4 is equal to k times minus 27. So k is equal to 3/4 times 27, which I'm not even going to attempt mentally, which is 1/36. So therefore, I can say that minus 3/4 t to the minus 3/2 equals minus 1/36 I. So the I parts here are minus k, which is minus 1/36, and that has to equal to the I parts here, which gives me an equation that I can solve for t. So I can immediately say that t to the minus 3/2 is going to be equal to, the negative signs cancel. So it's going to be 1/36 times 4/3, which is 1/27. Now you're going to use your power laws here to say that 1/t to the 3/2 is 1/27, which means that t to the 3/2 is equal to 27. I'm going to cube root both sides to say that t to the half is equal to 3, and then square both sides to say that t is equal to 9 seconds. Oh, thank you very much, Krish. Happy to help. Right, so, okay, that seems fine. Now, yeah, you see I'm kind of blitzing the mechanics entirely. So here, we've got a projectile. Again, I see a 10 alpha. We know what I'm going to do. I'm going to ignore the rest of the question and immediately just work on that. Nope. So I'm drawing my triangle with an alpha. That's opposite over adjacent, so that's 3/4. I know that's going to be a 3, 4, 5 triangle, which means that cos alpha is 4/5. And sine alpha is 3/5. An initial model. The stone is modeled as a particle P moving freely under gravity. The stone hits the ground at A. Cool. Figure 4 shows the path. For this motion at time t seconds, horizontal distance is x, vertical distance is y. Show some nonsense. Okay. How are we going to do this? First of all, I'm not going to have room to do it here, so I am going to have to copy down. But I know with projectiles, you need to split it into the vertical and horizontal. I know that the vertical, you will be doing SUVAT. So for SUVAT, S-U-V-A-T, the vertical is going to minus 9.8. It always accelerates with g downwards. The u is going to be equal to, well, let me split this on the diagram. So this would be u vertically. It's going to be 35. Opening up means it's sine, so 35 sine alpha. But 35 sine alpha is 35 times 3/5, which is 21. So vertically, it's going to be 21. And horizontally, it's going to be 35 cos alpha. But cos alpha is equal to 2/5. So it's going to be 4/5 times 4/5 is 28. So initial speed is going to be 21 upwards, which is why it's positive. This is downwards, the acceleration, which is why it's negative. We know that the vertical distance is going to be y, and we know it's in terms of t. So I'm going to leave it in terms of t. We also know that horizontally, we just have distance equals speed times time. The distance is equal to x. The speed is always equal to this 28 we worked out, and the time is t. So what we know is horizontally, we have distance x is equal to, so we have that the distance x is equal to 28t. And then from the vertical, we can say that s equals ut plus half at squared, which means that y is equal to 21t minus 4.9t squared. And this is parametric equations. We need to express the y in terms of x, which means we do not want the t. So we're going to have to say from here that t is equal to x over 28 and substitute that in. So this would be equal to 21 times x over 28 minus 4.9 into x over 28 all squared. So doing that, I'm going to get, now let's do it in the language of the question. So it's exact fractions. So that gives me my 3/4 x, that term. Now if I do 4.9 all over 28 squared, I get 1 over 160, which is exactly what they get. Cool. Minus 1 over 160 x squared. Great. So that's how to do that. So using this answer, find the length OA. Well, OA is the horizontal distance, and A is the point when y equals 0. So I'm going to solve that quadratic. So if y is equal to 3/4 x minus 1 over 160 x squared, I'm going to solve for when y equals 0, and I'm going to factorize out an x. So I'm going to get x into 3/4 minus 1 over 160x. I know that y equals 0 when x equals 0 because that's the point O. So clearly the a value is going to be from the other factor there. So either x equals 0, this is at point O, and I'll make a note of that, or 3/4 minus 1 over 160x equals 0, which means that 3/4 is x over 160. And then 160 times 3/4 gives me that x is equal to 120. Sweet. Now, using the model, let's be diligent here. Meters, right? So using the model, the greatest height of the stone above the ground is found to be h. Use the answer to A to find the value of h. well, the greatest height is going to be, you have a quadratic, greatest height is going to be done in one of two ways. It's either going to be from differentiating or from completing the square. I prefer completing the square, although these numbers aren't great, so maybe you will prefer, but completing the square gets me everything in one go, so I'm going to do that. So from C, I know that y is equal to, I'm going to rewrite it in a way that helps me complete the square, minus 160x squared plus 3/4 x. So I'm going to factorize out the minus 1 over 160. I'll be left with x squared. Now, what happens when I factorize that out? I have to divide 3/4 by minus 1 over 160. And I could even do that. I'll do that like as like you would do it. So a fraction on a fraction. Minus 1 over 160. And it does give me what I expect, which is minus 120x. So I factorize that out. Now I can complete the square. So it's equal to minus 1 over 160 into, that's going to be x minus 60 all squared minus 3600, which is 60 squared, which immediately tells me my maximum height is going to be when x equals 60, which in the mark scheme, maybe they'll allow you to do straight up. But I'm going to say it's x minus 60 all squared. And I'm going to say 3600 over 160 is that the minus and the minus make that a plus. 45 over 2, which is 22.5. Therefore, h, the max height, is 22.5 meters when x equals 60. Okay. Model is refined to include air resistance. Using this new model, the greatest height of the stone is found to be k. State which is greater, h or k, justify your answer. Well, I mean, clearly h is going to be bigger. And I'm going to use it like in my head, I'm thinking about this in terms of physics, where all that kinetic energy gets to go into GPE. I'm not sure whether they like that. Justifying your answer. Include air resistance. Air resistance. I'm just gonna go for it. Air resistance takes slows it down, or it takes energy away. I'm just gonna give the physics answer. It takes energy away, so not all the kinetic energy goes into GPE. I don't really know exactly what they're looking for there, but so I'll just write like, and this is what you do, right? If you don't know exactly what they're looking for, just use a scattergun approach. Just write like, when they say justify your answer, they don't say state one reason. So in a situation like this, I'd be annoyed at them for not giving me more clarity. And I would write like a full paragraph and be like, you know what, find the mark. Find the mark. Like, just give it to me. State one limitation of this refined model. So it's air resistance, but it also treats the stone as a particle, something like ignores the volume or rotation of the stone. So something that indicates that the stone is a particle, right? And that's a problem. Accuracy. And then finally, yeah. Oh, it's a shame. I wanted a really good Suvat, guys. No, it's fine. It's fine. You can't get everything in one paper. Okay. We love moments in 2D. So uniform rod of mass. So it's uniform, so the mass acts in the middle. Its length is 2a. In moments, this is very important. I write all my local distances. So the mass is m, and I'm going to write that. I'm going to split that into a and 0.5a. I really want, whenever I look at a section, I only want to know the distance between the two bits on the end. My brain gets confused when doing this whole like 1.5a with big arrows. So with any moments question, draw your local distances. Local meaning just between the 2 points that it like right there. So this is rough horizontal ground. There's going to be a reaction at A, and it would want to be sliding to the left. So there is a friction acting to the right. The rod rests in equilibrium, a smooth fixed peg. So that reaction force at C will be acting at right angles to the rod. The reason why is because the rod is in contact with the peg, which means there is going to be a normal reaction force to the peg at that point of contact. And you know that at that point, the rod is a tangent to the circle. And what's perpendicular to, at that point would be the radius. So the tangent and radius are perpendicular. So if we want a point that's like a direction that's perpendicular to that point of contact, it will be perpendicular to the rod because the rod is parallel to the circle at that point, and it has to be perpendicular to the circle at that point. Sorry if that, let me try that again. So reaction forces act at right angles to the surface that you are in contact with. So it has to be at right angles to the circle at that point, which means, but what is the circle doing at that point? We can mark that by the tangent, which is the rod. So in order to be perpendicular to the circle, you have to be perpendicular to the tangent. And in order to be perpendicular to the tangent, you therefore have to be perpendicular to the rod. I think that explains it okay. So the point C of the rod, given by that, point in contact between the rod and the peg. Okay, we've got another one of these. So if tan theta is 4/3, I'm going to blindly stop what I'm doing. Theta, opposite is 4, adjacent is 3. This is a 3, 4, 5. And this means that cos theta is 3/5 and sine theta is 4/5. So I'll have that when I need it. Magnitude of the normal reaction at C is S. So I'll rename that. So with any mechanics question, look how I'm organizing the data, right? I'm organizing all of the words of the question in a good diagram. And once that's all organized, then I can think about actually going through the math. So now we want to show that S is 2/5 mg. I'm going to do that by taking moments about A. The reason why is because I don't know these two forces, and by taking moments there, I can ignore them entirely. Yep. Right, so we've got, to do moments, we need the clockwise moment will equal the anti-clockwise moment. So A times, well, I'm going to think of the vertical, the force is vertical, and the horizontal distance there would be A cos theta. So AMG cos theta is the anti-clockwise moment. Sorry, it's the clockwise moment, and that will be equal to the anti-clockwise moment, which is 1.5 s, which means that, remembering that cos theta was equal to 3/5, so 0.6 AMG equals 1.5 s, and 0.6 divided by 1.5 is 0.4. So 0.4 AMG is equal to S, which is 2/5 AMG, which I think is what they wanted. Oh no, where's my A? Because it was 1.5 A is my distance. Okay, got it. Cool. Got it. The coefficient of friction between the rod and the ground is mu. It's in limiting equilibrium, which means that F is equal to mu r. So we got to find the value of mu. So typically one of these would be, so this is equilibrium, right? So in equilibrium, we know that the clockwise moment equals the anti-clockwise moment, but we also know that the forces resolve in every direction. So by resolving the forces vertically and horizontally, we'll be able to find this. Resolving vertically, we have that. Well, if that's 90 degrees, now this is, by the way, let me, if you have trouble working out angles, by the way, this can help you out. So what we're going to do is draw. I'm going to get rid of this triangle and this stuff so you can see it a bit better. So I'm going to consider what's happening around P. And I'm going to consider a sort of X on top of a cross, like a plus, right? So what we know here at the very start, just by corresponding angles, we know that angle in there is theta, right? If you ever get stuck, as long as you work out one angle, you can just go around alternating 90 minus theta, theta, 90 minus theta, theta, 90 minus theta, theta, 90 minus theta. And this will help you work out any angle you're looking for. So here, if we want to resolve vertically, we want this one here. Well, that's theta as well. And you can kind of use this to work out any other angles that you need, because some people really struggle with that to see it. So as long as you get one right, you'll get them all right. So here, the vertical is going to be S cos theta. We're going to add to that the reaction force at A minus mg equals 0. Now, S was equal to 2/5 mg, and cos theta is 3/5. So multiplying those together, I will get 6/25 mg plus r minus mg equals 0, which means that the reaction force there is equal to mg minus 6/25 mg, which is equal to 19/25 mg. Cool. Now we can do the similar thing to work out the frictional force by resolving everything horizontally. So resolving horizontally, in that direction, it would be F is equal to S sine theta. And sine theta is 4/5, so it will be equal to 4/5 times this guy, which would be 8/25 mg. And finally, we know that F would be equal to mu r. So 8/25 mg is equal to mu times 19/25 mg. Now the over 25 is going to cancel, the mg's are going to cancel, and mu is just going to be equal to 8/19. Great. So it looks like I did that in no time at all. I'm going to check the mechanics first because I felt more confident. Now, realistically, I kind of did these in the order because I knew I was going to find the mechanics more fun. In the real thing, maybe you want to start with what you think is more fun. That's going to give you more confidence, really set the tone. What I'm going to do here, checking is a lot harder in the stats in Mech. It's much more so in the pure, but let me see. If I'm just going to kind of rerun this. The magnitude of the normal reaction is just 0.5 g. That is just correct. Horizontal force of x. It's in limiting equilibrium, which means that x is equal to the maximum friction. So it is mu times r. And let me just check that was the case. Yeah, 1.4, fine. This, the acceleration of the first one, I said that was equal to 2.5. I'm going to check that by v equals u plus at. So u would be 0, a would be 2.5, t would be 4. Yes, I do end up at 10. That seems right. Find the distance covered in the first 18 seconds. I'm going to check this by working it out a different way. I'm going to work out the area of the triangle, which is 1/2 times the base of 4 times the height of 10. And I'm going to add on this rectangle, which has a base of 14 and a height of 10, and confirm that I also get 160, which I do. Find the value of u. I'm going to work backwards and say, if that's my value of u, what would this area be? So if that value is u, I'll even break it out into the rectangle and the triangle again. So it would be, no, I'm not. I'm still going to do trapezium. So u, I said, was 10/3, so I'm going to lock that in. And I would say u, so answer plus 10 all over 2 times the distance in between of 24 minus 18. I get the remaining 40 meters because it's a 200-meter race. This is good. So this question feels good. Here, find in terms of m and g the magnitude of the normal reaction at P. So let me first check my diagram was okay. The point was held on a rough inclined plane. So these angles, do these work? So it's opposite adjacent. So cos is 12, sine is 15. Yep, good. The magnitude of the normal reaction P is going to be mg cos alpha. So it's 12/13 mg is r, which is good. Show that, and I did show that, so I feel good about B. Say what would happen, it would stay at rest. I feel good about that. Going to here. Show that C is 3. I like what I did here. Well, let me put in C equals 3 and T equals 4. So 3 times 4 to the half is equal to 6. 3/8 times 4 squared is 6. And they're both 6. So there is 6i minus 6j, and 6i minus 6j would have a bearing of 135. So if it was 6 and 6, you'd have 90 there. This would be 45, 45. This would be 135. That works. So notice how I'm starting on my answer and working backwards to a given value. So I said if T was 4 and C was equal to 3, what would the bearing be? Good, I get 135. So even if you couldn't get that, by the way, if you can use the fact that C equals 3 and T equals 4 to work out the speed. So speed you get by differentiating. So it is equal to 3. Let me make sure I differentiate it correctly. 3 over 2, T to the minus a half. Good. Now, if T is equal to 4, 3 over 2 times answer to the minus a half is, in fact, yep, 3/4. And you would get, then let me just double check this. So 3/8 times 2 is my 3/4 times the T of 4 is equal to 3. And then the square root of 0.75 squared plus 3 squared is, maybe they want it exact, actually. Hold on a minute. Let me do this exactly. So the exact value my calculator gives me is 3/4 root 17. And maybe I'll also say that's equal to 3.09 meters per second to 3 significant figures. So these sorts of checks are things that I would do to sort of tidy up my work. I don't know whether they want it exact or rounded, so I'm going to give both. I'm going to give the precise value and then give the rounded value. When T equals big T, P is accelerating in this direction, find the value of T. Well, what I'm going to do, first of all, like, did I differentiate this correctly? Minus 3/4 T to the minus 3 over 2 is correct. Minus 3/4 J, good. Can I check? I'm going to plug in my answer of 9 seconds into here and see what I get. So if 9 equals, and then I'm going to do minus 3/4 times answer to the minus 1.5, and I get minus 1 over 36. So the acceleration would be equal to, so when T equals 9, then the acceleration would be equal to minus 1 over 36i minus 3/4 J. And if I multiply everything by 36, so in fact, if I take a 1 over 36 out, I would be left with minus I. And then I would do 3/4, which is 0.75 times 36, which would be, yeah, minus 27J. So that works. So I feel good about that. Then here, use the model to show that. I did show that. Use it to find the length of OA. Well, what I'm going to do is I'm going to plug in my answer. So I got an answer that it was equal to 120 meters. So let me plug 120 back into the equation and confirm I get 0. So 3/4 answer minus 1 over 160 times answer squared does give me 0. So that seems correct. Use the model. The greatest height is found to be h. use the answer to find the value of h. So that's this quadratic. I'm going to calculate this a second way. So I'm going to differentiate this and set to 0. So that would be 3/4 minus 1 over 80x would be equal to 0. So 3/4 equals x over 80, and x would be equal to 60. Let's plug in x equals 60, so 60 equals, and then 0.75 answer minus answer squared over 160 does in fact also give me 22.5. So I like the fact that the greatest height is 22.5 meters. And rereading the question, it's found to be that. Use the answer to A, find the value of H. I did that. Models refined to include air resistance. H is going to be bigger, certainly, and thingy. Right, what I didn't do, and I'm going to do it after I check this next one, but I didn't. The first thing I should have checked, based on what I did last time, is to check to make sure I actually did every part of every question. Okay, so here, show that S is 2/5 mg. I did show that. Find a value of mu. Well, what I'm going to do is I'm going to use that value of mu as 8/19 and see what that would do. What's another way I could have calculated this? I could take moments about the center of mass, which would be quite fun. Suppose that would be another way of checking this. So let me try that. Let me try taking moments about the center of mass using this value of mu. Because if I did that, so moments about the center of mass, let's consider the clockwise moments, which would just be r. And now this would be 90 minus alpha, which means that, so again, look at how I'm using this idea of the sort of cross. So the horizontal one is theta, so that's 90 minus theta, so that there is theta. So it would be r cos theta acting at a distance of a would be the clockwise moment, and then the anti-clockwise moment would be given by 0.5 a times s plus a times f sine theta. Well, f would be equal to mu r, so that would be 8/19 r. Let me plug this in. So cos theta, so 3/5. So 3/5 RA. Well, that's this reaction force. Oh, but I suppose I don't know that in terms of mg then. Maybe it'll work. Let's find out. Equals 0.5 AS, so that'd be 1/5 MGA. Plus 4/5 A times mu times R. So the A's would certainly cancel. The fifths would certainly cancel. That would be 3R is equal to mg plus 32/19R. That would work out mg for me. I don't think I'm getting the same thing. I really don't think I'm getting the same thing here, because this would be saying that 3, maybe I've just done something wrong in the way I've checked it though. But this would tell me that R is equal to 25/19 mg, which is not correct. Have I done something wrong, therefore? Did I divide them the wrong way around at the end? Doesn't look like I did. You are f sine theta certainly. Okay, maybe I don't like the way I checked this. This seems a little bit convoluted. So, okay, that's not cooperating. That refresh rate. Okay, calm. It's all right. It's all right. I'm not going to stress you out too much. Okay, so let me instead check what I did. Show that S is 2/5 mg. I did that. Does this now work? So vertically, that would be, that's theta, that's 90 minus theta, that's theta. S cos theta vertically plus R equals mg. So that is 3/5 times 2/5, which is 6/25 mg. And let me just check that 1 minus 6/25 is 19/25. Good. So that is the vertical reaction force. And then horizontally, we would have S sine theta equals F. And S sine theta is that times, so it is 8/25 mg, and that is F. And F equals mu times R. I do think that works. I'm kind of happy with it. I don't know why my checking went so disastrously wrong. Like in theory, it should have worked. But in the interest of time, I think I'm going to check the stats. No, I'm not. I'm going to check that I've answered every part of every question because I'm not a numpty. Right, so I have an answer for the A. I have an answer for B. Good. I have answered that. I have answered that. I've answered that. So what I do here for checking this is I check whenever I see bold marks. I've done that. I've done that. I've done that. Here, done it, done it, done it. Find the value of t. I've got a value of t. Okay, here, done it. 2, 3, 4, 5. Yep. So 3 proper, 1, 2, 3 proper working, and then 2 done in the paper. Good. Now here, have I done 1, 2? Yes, I have. All right, so I've answered every part of every question. Let's go check the stats. Here, have I answered every part? Find these. Found them, found them. Found, yep. Yep. Have I answered I've answered all of those. Here, I have answered that. I've answered that. I've answered that in words. And I answered that. Did it. Mean and standard deviation. Did it. Suggest I did that. Again, I did that. Yeah. Yeah. So here, I did that. Yeah, done all of those. Answered. Well, then where's A? Find the report. Did I answer A? Yep. And then B, yep. And then C, I think I did. And then D, I did down there. Although, did I? Hold on a minute. Yeah, that was. Got it. Apparent. Okay, so this was actually C. And this was actually D. Cool. That's all in. Now, have I answered that? Yes. Find the value of P. Yep. Find the greatest value. I did that. D, I did. E, I did there, and F, I did up there. Good. So I answered all of those. Great. Every part is answered. Now let's go checking. How do you check stats? Like I say, I calculated the first one 2 ways anyway. I did it by hand, and I did it on the calculator. This one, just making sure I did the correction right. So less than 3 is less than or equal to 2. And if I really wanted, I could add the 0, 1, and 2. I'm not going to do that. I'm happy with how I did that. What I am going to do, though, like I said before, is I'm going to type it back in and make sure that I didn't accidentally forget to round. So variable x, the CD on 2 for n equals 10, and probability is a sixth. Gave me, yeah, that's perfect. Repeats every day for 60 days. So we have a new variable distributed with 60 and 0.1550. Find the probability that there were at least 12 days is 1 minus the probability of there being less than or equal to 11. So 11 with n equals 60 and p is 0.1550. Yep, 1 minus that. Is that good? Estimate for the total number of sixes in 60 days, rolled 10 times, 600 rolls. Probability is a sixth. Number is 100. That's fine. Continuity correction for this. So going from 95 in discrete, we want it to be bigger than 95, so we do not want it to include anything between 94.5 or 95.5. We want it to start from 95.5 up to make it continuous. So in the normal, it is bigger than that, absolutely. So we go to the normal distribution. So that's normal CD with a lower of 95.5, an upper of something times 10 to the stupid. Sigma, we said was 9.1287. Yeah, the squared is there, good. And the mean is 100. And I do get 0.6890, which I like. Now, hold on, what could I do here? What I could do here to check is to actually do it properly using the binomial and see how close that is. So in the binomial, it would be 600 rolls, and we would want to do 1 minus. So if this was binomial, so it's more than 95. So the probability of x being more than 95 is 1 minus the probability of x being less than or equal to 94. And you can get there using, once again, in stats, number line, number line, number line. Oh, you see, I got this wrong because I didn't use my number line. So if you want to be bigger than 95, you want to be 96 or bigger, that's in. And you get rid of 95 and below, that's out. So it should have been 1 minus the probability that x is less than or equal to 95. Okay, so I'm going to do 1 minus the CD of 95. So x is 95, n is 600, and probability is a sixth. And I get 1 minus 0.3143, which is 0.6857. Which is a little off, but close enough to this. So there's a small, because it's an approximation. So I'm feeling good that these numbers resemble each other, which makes me feel good about question 1. Question 2, interpret the gradient. Downward speed of 1.82 meters per second, done in the language of the question. H naught is always PMCC equals 0. In this case, we want a negative correlation, so PMCC is less than 0. You look up the critical value for n equals 10, and one-tailed 5% means it really is a true 5%. So 10 values and 5% was 0.5499. This was insufficiently extreme to reject it. You need to be more negative than 0.5499 to be significant. This does not meet that threshold, so we do not reject, and we conclude, and you write your conclusion sentence restating it in the language of the question. Here, they love this. Is the linear appropriate? Well, it's appropriate if the data points lie close to a straight line. These data points do not lie close to a straight line, so you cannot fit a linear model. And here, we know that when t equals k, that gives you the maximum. Maximum here is when t equals 3.5. So k, I'm going to say 3.5. That looks fine. Still got 14 minutes, which is great. So here, I like daily max wind speed as the large data set answer for that. Calculate the mean and the standard deviation. Really nothing to it apart from just recalculate it. And if you got some fancy, I think there are some calculator buttons you can press that do this for you. I don't know them. because again, like the absolute worst part of my game is calculator use. And if you watched any of my ESAT prep, you'll know why. Because I'm I'm used to doing things non-calc. So the mean is 15.22, good. And this, by the way, these equations, if you want to know where they came from, they are here in the formula book as well, so you don't need to worry about memorizing them. So let me show you where I'm using this here. I'm using the second form. Sum of x squared over n minus the square of the mean. So that's what I did here. So I said it was the root of, hold on, my answer was that. So I said it would be the square root of 44695.4 all over 184 minus that mean squared, gives me 3.338. I feel good about that mean and standard deviation. Suggest when the temperature is that in Perth, which is Southern Hemisphere, Australia. So I would expect the coldest month of October in the Northern Hemisphere to be the warmest month in the Southern Hemisphere. So yeah, that's all good. Then here, let me make sure I did okay here. So this is a binomial hypothesis test. Null hypothesis is what you sort of default is that the probability is 10%. You want to see if it's different from 10% with no sense of direction. So it is that the null alternative hypothesis is that probability is not equal to. To find a critical region, we want to find where you get rejected at 2.5% in each tail. And I found that the probability, let me just rerun this, the probability from a list. In fact, I'm just going to check these transitions. So I'm going to do binomial CD. I'm going to do a list. I'm going to try 0 and 1. And here the transitions were 7 and 8. For n equals 40, and the probability of success is 0.1. And I do find that 2.5% lies between those, and 97.5% does lie between those. I'm going to click in and make sure, yep, so that rounds up to the 8. This rounds up to the 805. This stays. Nope, that's 9581. That is 9845. So I'm just checking my rounding. That's all good. So the probability using, and again, I'll write my number line here just in case you need it. But number line here, probability being less than or equal to 7. So if that's out, then this is in, which would be 8 and above, which is why I said it's the probability that x is bigger than or equal to 8 is this other guy. So probability of x being bigger than or equal to 9 is sufficiently extreme, and x is equal to 0 is sufficiently extreme, which is why that's your critical region. And your actual significance level is the sum of those probabilities. Let me just go back. I want to just check something real quick. So I'm going to go back to calculator mode. The answer was no. Okay, so it didn't store the values from the table, but that's fine because I have them written down. I'm just checking that 0.9845 subtracted from 1 does indeed give me this probability, which it does. And if I add that onto the 0.0148, I do get the 0.0303. That's good. 7 is not in the critical region, therefore do not reject, and then restate in the language of the question. This looks fine. 10 minutes on the clock. I'm going to be fine. So this is just normal. And like I say, I checked that against what I expected, right? I expected it to be a little bit less than 0.16, which it was. So I feel good about that. I can rerun it because I have the time. This is a less efficient mode of checking, but I'm not too mad about it, again, just because I have that time. So 0.16 goes up to 9 times 10 to the stupid. 0.15 standard deviation, mean of 1.4. I do get that to 4 decimal places. For this board, probabilities are always 4 decimal places. For OCR, it's more of a 3 significant figures, or maybe a 3 decimal places. Know your board and what they like. Excuse me. Just gonna drink. Apologies. This was meant to be C. So I do get the probability for A. In order to multiply them together, you need to have the B independent. So the probability that T is less than 300. Yeah, I'm just going to run this again because I have time. Normal cumulative. Lower is minus 9 times 10 to the stupid. Upper is 300. Sigma is 26. Mean is 330. I do find 0.1243. And then if I go back to calculator mode, then answer times the 0.0912 I found earlier does give me this probability. Good. And what I'm going to do now is I'm going to use my values that I found for D. I'm going to plug them back in and check I get these probabilities. So working backwards from the values I found to use the given values to find. So if I have 20, let me put normal distribution, normal CD. On this one, I'm going to try lower is minus 9 times 10 to the stupid. Upper is 16.3. I'm going to try putting in my mean of 20.0, my standard deviation of 7.03, my mean of 20, and I get 0.3, well, basically 0.3, which is good. And in fact, it is 0.30 to 2 decimal places, so I feel good about that. And then if I do a lower of 29 and an upper of 9 times 10 to the stupid, I do get 0.1. So I've used those answers to get my probabilities back, so I feel good about that mean and standard deviation. And here, finally, A and C are mutually exclusive because no overlap. B and C are independent, find the value of P. What I'm going to do is to rerun that to check that they're independent. So using that value of P, well, the value of B, the probability of B would be 0.05. If I just go back to calculator mode, 0.05 plus 0.13 plus 0.27 gives me a probability of 0.45. The probability of C is 0.27 plus 0.25 plus 0.08, which is 0.60. If I multiply those together, I get 0.27, which is the intersection, so that does work for independence. Greatest possible value of probability of A given not B. So is it true that the biggest possible value of that would be... So in other words, so what that means as well is that's a proportion of the A parts of the not B parts. So it is Q all over this whole remaining thing. So it is Q over 0.55. Let me just check that it is. So 1 minus 0.05 minus 0.13 minus 0.27 is, yes. So it is Q out of that. And the biggest Q can get is 0.22. And I think I liked that from before, but I'm just going to rerun it just to be extra certain. And yep. So the biggest that could be is 0.22 out of the 0.55. Yep. So the 0.22 out of 0.55 is 0.4. That is the biggest that could be. Right. So what I'm going to do here is I'm going to use my values of Q and R to work out probability of B given not A. So probability of B given not A is 0.4. And what's the probability of not A given the values that I worked out? The probability of not A is 1 minus 0.15 minus 0.05, so 0.8. So 0.4 over 0.8 is 0.5, and that is correct. Here, find, so A unioned B is all of these guys. So not that, is all of these guys. And this is for the same condition as before? Yes. So it is 0.07. Well, it's these sections, but I want to intersect that with C. So I can only keep the parts that are in neither A or B, which is these three, but only keep the parts that are in C, which are these two, which is 0.25 plus 0.08, which is 0.33. That feels good. Use set notation to write an expression for the event with probability P. So similarly to here, we have something unioned, knotted, intersected with something else. So here, if it's neither A nor C, that's A union C, not that. So get rid of all of those. And from what's left, you have only these two, which you then intersect that with B, and that gets you just P. So I feel good about that. I have now checked all of my work. I've got time left on the clock, only 3 minutes, but 3 minutes is 3 minutes. So I'm going to stop the time, mark it up, see how I did. Okay, so let's mark the stats up first. So the stats, first thing, answer which rounds to 0.155, good. Oh no, yeah, they do like 3 significant figures, that's fine, shut me up. 0.2155, good. 100, 0.689 for D. That was the true one. Yeah, 689 here was correct there. Good. So that was all correct. Now let's get the language of this one. The height decreases. Okay, let's see if they would have allowed. Okay, so that's not what they were going for. I went for too physical an interpretation. They just mean for gradient, they wanted it in the most general possible sense. They want it in this language. As t increases, what happens to h? So for every 1 second, for every extra second, the height decreases by 1.28 meters is what they wanted. Okay, so that's good to know. I tried to interpret the meaning too much, but I should have stuck more to the syllabus. What does a gradient mean? As thing on the x-axis increases, what happens to thing on y-axis? So for every 1 second, height decreases by 1.28 meters. For B, h naught p equals 0, p less than 0, critical value 549, and it's not sufficient. So there's not evidence of a negative correlation between height and time. Good. For C, it doesn't fit a straight line, seem to follow a curve, or since it doesn't fit a straight line, so you can't use a linear model. Great. So I said suitable K. I said K is 3.5, so I get that. That's good. So here, okay, drum roll, please. Rainfall. Oh, the mean wind speed. No. Hold on, let's see if they allow max wind speed. Not max wind speed. No. Oh, God. Stupid large data set is stupid. That was such a sensible guess. Okay, so mean wind speed they would have allowed. But for precipitation, that's such a large amount of precipitation to have an average of that, an average of 5.3. An average of 5.3. That seems so high. All right, well, I got that one wrong, but the mean was 15.2. 15.2, standard deviation of 3.34. So it's southern hemisphere spring. What's the month? October? It's October, right? Oh, just any summer, spring month. Month is October. Great, got it. Okay, cool. So here, question 4. P is 0.1. P is not 0.1. So I got, bigger than I got the critical value region. Good. And the true is 0.303. Yep, good. Insufficient evidence. Good. Then here for 5, 0.0912. Good. They need to be independent. 0.0113. Good. Mean is 20.0. Standard deviation of 7.03. Good. And finally, A and C is good for 6A. The value of P is 0.13. Good. For C, 0.04. Good. Q is 0.15. R is 0.07. Correct. 0.33. Good. And I said it was the intersection of B with A union C nodded. Great. So that is everything there apart from the large data set. The large data set, I swear to God, will be the source of so many marks lost. But going into the mechanics, let's kind of see what's up. So 4.9 newtons, good. 1.4 newtons, good. 2, find the acceleration. It is 2.5, good. 160, and then 10 over 3. Okay, but like, where's the answer though? Okay, 10 over 3, good, got it. So 3, let's make sure I didn't do anything silly. Find, in terms of NMG, I said it was 12/13 mg, good. I did find that, good. P wouldn't move, stay stationary, good. Never in doubt. 4A, oh, there's some nonsense happening. Oh, why is there nonsense happening? That's too much for 4A. So for 4A, show that. Oh yeah, the argument, yes, the language. Okay, so yeah, 45, 2C and 6. So, or states isosceles triangle, so 2C equals this. Good, that's kind of how I did it. The speed, did they give it exact or rounded for B? Both. So I said 3/4 root 17 equals 3.09. So that's belt and braces. Totally got that. Absolutely fine. And then find the value of T should be 9 seconds. Great. And then 5, show that I did. Let me see. So for 5, it starts here. Yep, so find the value of T, substitute it in. Great. And then B, how do you do it? So you find the length by saying y equals 0. Do you? Yeah. Why are they differentiating and setting to 0? Oh, because it's double. Okay, symmetry, don't like that. But the point is it's 120. And then here for 5C, find the value of H is at 22.5. Yes, it is. For D, H is greater. What as air resistance would slow the particle down? I did say that. Slows it down. Great. So you'll notice I just wrote everything and went, great, where are you going to give me my mark? Just give me my mark. Inaccuracy of using 9.8 for G is an example, but they have loads of examples. So let me check the alternates for 5E. Spin of the stone. I said rotation. Size, volume of the stone. I said all of that, right? But it's good to know that their prominent one is the use of 9.8 for G is inaccurate. Interesting. So you can take that moving forward. And then for question 6, show that S is 2/3 mg. I did most certainly that. Now for B, is it 8/19? Yes, it is. All right. So I'm feeling good about that. Only lost a single mark there, and that was due to the large data set. And I think that doesn't count as a valid question anyway. Large data set is stupid, and I hate it. So I'm feeling good about that. Hopefully that sort of shows you my thought process, my kind of exam technique for moving through a paper, different ways of checking, which again are different for the stats in Mech. So notice how with the stats, I was doing things like with the normal curve, I was checking on what I expected a value to be and seeing how that matched up. Or when I had the normal approximation to the binomial distribution, I actually calculated the binomial distribution to check that it was quite similar, or found a way of plugging in a value that I calculated. So something like plugging in my value for the mean and standard deviation back into the normal to get back those probabilities. So some way of reworking it that isn't exactly the same thing you did forward again, just in case you missed something the second time as well. Mechanics was a bit more straightforward. So again, finding ways to put the answers back in and make sure that your sort of like answers hold up. So that's how I think you should move through a stats and mech paper. You can obviously answer them in any order. I think moving forward, I will go with mechanics first, just because it moved so quickly, so fluidly, and gave me, that would be the sort of where the confidence is, and that would build me up the time bank that I know I could spend then on the stats paper. So that's the only thing I would say in terms of exam technique. I would also say for me, if I was revising, I would look at that performance and think, okay, I need to do a lot more work on my calculator skills to make sure I know all the tips and tricks, all the buttons to press to make my life easy. And I would also tell myself to go back to the large data set and learn in more detail what the different column headings are, what types of data they include, and what my expected values are. So I've seen ones before where they expect you to know that the values of pressure, for instance, are around 1010 hectopascals or whatever that unit is. So large data set. They're free marks if you learn them, and you lose them if you don't learn them. So definitely worth doing. Right, so hopefully you've taken some good stuff away from that. I'm going to end there. I will not see you on Wednesday on account of I am going on holiday. So hopefully when I come back, I will be refreshed and relaxed and ready to go to sort of move through to exam season. Now, in the meantime, take care. Have you guys a good week, and I'll be back probably next Monday for another live solve. All right, take care. I'll see you then. Oh, wait, question. Common question. I'm not ignoring that. How do I study physics? Because no matter how much I study, I seem to do bad on physics exams every time. You're going to have to, okay, what you should do, here's how you analyze your performance. Go take your physics paper and find the marks you lost and decide what category there are. There are 3 categories of mistake you can make. Conceptual error, where you just didn't understand the concepts of the question. How you fix that is to just revise more. Go back, make sure you know what's happening. Another type of error is an execution error, where like you know the concept, but like, oh, god damn it, I just plugged in the number wrong. I rearranged it wrong on my calculator. I made an annoying mistake. And the third type is an exam technique error. So something like misreading the question or misinterpreting the question. Like you reading it correctly, but like what is the question actually asking, which is a big problem in physics. So that would be playing the exam game. That would be things like looking at mark schemes and using them to work out what the question was really asking. So execution is, so basically exam, like conceptual issues, hit the book again. Execution, hit the practice questions again. Exam technique, do all the past papers and do all the mark scheme analysis and really keep a track of what your exam technique issues are. So for me, that's why I was like, oh, I need to make sure I've answered every part of every question. So you kind of get better that way. So that's how I would do it. I would make it very active and not just sort of passively reading the book, unless, of course, conceptually is where your biggest issue is. So hopefully that makes sense for you. I will see you guys next Monday for another live solve. All right, take care. I'll see you then. Bye-bye.